This last video is supposed to be very, very short. I'm going to add a little bit of functionality by finding a unit vector. We're going to find the component of A in the direction of B, and we're going to find the projection of A in the direction of B, right? So A in the direction of B. So that's all we're going to do. We're going to do these three things, and it should be maybe 5 minutes, I hope. All right, so we've did the set decimal def unit. All you got to do is throw in self, and it returns the unit vectors. That's what we're looking for. And then so it's return vector 2D self x divided by self norm, comma self dot y. Okay, so hopefully that works. Shift enter, add a dot. Set that to u, and then u dot set decimal to maybe 3, and then print u. Didn't like any of that. Oh, I didn't do MP. Shift enter, shift enter, shift enter, shift enter. Has no attribute set decimal. U is a. Oh, it's not a dot norm unit. Try it again. All right, so we see that this sucker finally worked after I got out all of my bugs. Just to make sure that we know that what that's doing. So a unit vector. So give me any vector A. Here, let me do this in yellow. Just the mathematics real quick. So give me any vector A, and if this thing's bigger than 1, then I will rescale it back down to point in the same direction and have a length of 1. That's all you're doing. If it's smaller than A, then it'll make it a little bit bigger. So, or however big it has to make it. All right, the next one is the component. So all the next part is take A and project it down onto B and tell me how far that is. Tell me how big that vector is. So that's this component business, and that's the length. And then the next part is the projection is, well, if that's the length, then multiply that by the unit vector of B in order to get this V. So basically that's the length, and I'm multiplying it by this unit vector of B in order to get the projection of A onto B. So that's all we're doing. So I'm going to do the mathematics for these things, and hopefully, it won't take too long. So let's see, def. So these are methods. So my next method is the component. Self. And a dot is equal to self times. Oh, I need a vector. Let it be V. Self times V. And then we'll say the magnitude to vec norm. So A dot B, so that's the first part, divided by the magnitude of, it's not vec, it's just V. V dot norm. Then just return that number. Return AB dot. I probably could have done this all in one step, but that's okay. F, hopefully this is a little bit easier to read. The projection is self. And then the scalar part is simply the self, oops, not minus equals self of self in the direction of V. automatically pass itself in. So self dot component of v divided by v dot norm return v dot x times v dot y. All right, so scalar's that part that's all over there. Let me make sure that's right. Norm. Okay, norm squared is, okay, so why am I not multiplying by norm squared is the question. I think I should. I might have to check this. So that should be, scalar is going to be the component of v. Oh, no, it's not. Okay, never mind. Because the component of v has a norm in there already. Okay, that's why we didn't do it. All right, let's test it. Shift enter, and then I'm going to let control enter, and then let's put p is equal to the component. Let's just print this off a dot. So self man. Try it again. All right, so we're getting that guy. B dot component in there. A should give us a different number. That's good. And then we want to print A dot projection in the direction. And now watch this. If I print P, it's going to give me this weird thing here, right? So I have to now say, and I got to say P dot set. Decimal. Try that. Okay, that's better. And then B in the direction of A. Okay, all right. So we have some things that are working for us. We're going to check them next class. We're going to plot these things and make sure that they make sense. So you'll be able to see that, if these vectors line up, that these projections are doing what they're supposed to do. In other words, if I'm going to see this vector, I'm going to see this vector, and I want to see this guy as well. So we'll do that next in the next set of videos when we start talking about variables that are over an entire class. So that's what we need to get to in order to be able to do that. Okay, that's all I got for this one. Hopefully it wasn't too long, and we'll talk at you next time.